Now we are going to the theory on how to calculate Laplace transform. We can write Laplace transform of f of t equals to integral from 0 to infinity of e to the power minus st into f of t with respect to t. Okay. Now this integral is an improper integral. Why? When upper limit or lower limit is infinity, then the integration is called improper integral. So how can we calculate improper integral? We can calculate first zero to some limit, 0 to some kind of limit. Then we will apply limit for that limiting value. So limit h tends to infinity. By this way we can calculate this integral. Here we first assume upper limit as h, then we will integrate, and then we will apply limit in place of h at h tends to infinity. H approaches infinity. Okay. Now how will we integrate? How will we integrate this portion? So first take the primitive shape. This shape is UV shape. This shape is UV shape. So this integration would be done by integration by parts. That is integration UV with respect to x or some kind of variable. That is integration of UV. Okay. So by UV method we will integrate this. Then we will apply limit. One limit is 0 and upper limit is infinity. Okay. Now we will go to the Laplace transform of exponential function e to the power lambda t or e to the power at or e to the power bt. But of course this coefficient, that means lambda, should be less than Laplace domain S. Okay. Now we will start Laplace transform of e to the power lambda t. First we will write Laplace transform of f of t equals to integral from 0 to infinity e to the power minus st into f of t with respect to t. And now we will inject in the place of f of t that e to the power lambda t. So in place of f of t we will write e to the power lambda t. Okay. Now 0 to infinity e to the power minus st. In place of f of t we will write e to the power lambda t. Okay. Now we will combine these functions. So e to the power minus st plus lambda t. Okay. 0 to infinity Now e to the power minus s minus lambda t. Okay. We know e to the power mx integration with respect to x is 1 by m e to the power mx. Okay, so this integral will be, here function is only one function exists, so we don't need integration UV method or integration by parts. If two different function exists, then integration by parts or integration UV is required. Okay, now we can write minus 1 by, this m should be minus s minus lambda, so 1 by s minus lambda, okay, into e to the power mx should be e to the power minus s minus lambda t. Okay, now we'll integrate from, now we'll plug in the limit 0 and infinity. Minus 1 by s minus lambda 1 by e to the power s minus lambda t, 0 to infinity. Okay, now that's the part, lambda less than s. If lambda less than s, then s minus lambda should be positive and e to the power s minus lambda t will be present in denominator. But if lambda is greater than s, then this term will be negative and this function will be present in numerator. And when you plug in infinity to numerator, then the result will be infinity, and the infinity result is not known. But here this function is in denominator because of lambda less than s. So now we'll plug infinity. If we plug in infinity, this function 1 by e to the power s minus lambda t will give result 0. So minus 1 by s minus lambda. So this limit when t tends to infinity gives us 0 minus 1 by e to the power s minus lambda into 0, that means e to the power 0, and that should be 1. So minus 1 by s minus lambda into minus 1. So the result comes 1 by s minus lambda. So we get the result is s minus lambda 1 by s minus lambda. Okay, so we get the result 1 by s minus lambda. Now Laplace transform of e to the power, if lambda is 0, that means e to the power 0 will be 1 by s, 1 by s. Okay, e to the power 0 we can write as 1. So Laplace transform of 1 should be 1 by s. Okay, this result and this result should be remembered throughout the whole course. Okay.